Screencast 5, this one's entitled Elasticity of Demand, and this is where the course starts to get a little complicated for people, especially with this concept of elasticity. So if things were easy for you up to now, great, but get prepared to put a little bit more thought into what you're watching, because it's going to take a little bit of thought to understand. So let's get started. First off, what is elasticity? If you'll remember, the law of demand says that when price rises, the quantity demanded falls, and vice versa. There is that inverse relationship between price and quantity. When prices go up, we don't buy as much stuff, basically. The concept of elasticity is about how much. Specifically, if the price of a good changes, does the quantity demanded change a lot or a little? That's what elasticity is about. It's a little bit more of a refinement dealing with the law of demand. All right, so to give you a sense of what I'm talking about, what if I showed you two demand curves, these two demand curves? I didn't label the demand curves or tell you what they were the demand for, but I did tell you that one of these demand curves is the demand for fuzzy bunny slippers, the ones you wear on your feet, and the other demand curve is for heroin, the drug. And I asked you to just think about, looking at the shapes of these demand curves, which was which. Pause it, think about it for a second, and see if you get the right answer. Maybe this will help you out. Look on the left-hand side. Notice here that the price, as we move from one point to the other point on the demand curve, is going way up. Big increase in price. Notice what happens to the quantity demanded. Relatively small change there. On the other hand, in the graph on the right, notice that when the price goes up just a little bit, the quantity demanded goes down a lot. Does it help you out? All right. The graph on the left might be the demand curve for something like heroin. That might make sense, right? People are addicted to heroin. So if you raise the price a lot of heroin, we're probably not going to see the quantity go down that much. People need to get it. On the other hand, no one on earth needs fuzzy bunny slippers. And so if you raise the price of fuzzy bunny slippers, you might see a large decrease in the quantity bought because people will buy other kinds of slippers. I have bear slippers. All right, that's what elasticity is about. We would say that the demand curve on the left is relatively inelastic, meaning that it doesn't change much. Quantity doesn't change much when the price changes. Inelastic, think like a rubber band that won't really stretch. The graph on the right, we might call that demand curve relatively elastic, meaning that quantity is very responsive to price changes, like a rubber band that stretches a lot. We can change the price just a little bit, and notice what happens to quantity. It changes quite a bit. Well, that's going to be the case as we go forward. Generally, the more vertical the demand curve, the more inelastic it is. And the flatter the demand curve is, like the one on the right, the more elastic the demand curve is. Now I'm going to get a little bit more specific about that because it's not exactly about the slope of the curve, but the slope of the curve tells us something about elasticity. So again, if we were going to look at the most extreme cases, the most vertical possible demand curve, the one on the top, we might call that perfectly inelastic. And think about what that means. No matter what the price is, whether it's $0 or $1 million, the quantity demanded stays exactly the same. That might be the demand curve for something like insulin for a diabetic, or for something like water for someone in the middle of the Sahara Desert. Right? It doesn't matter what the price is, you need a certain amount of it. On the graph on the bottom, we might call that perfectly elastic, a perfectly flat demand curve. Notice that as soon as price changes at all, the quantity changes entirely. All right, well, how do you determine actual elasticity given a certain demand curve? There's a few different methods, and the AP exam tests on all of them. Method number one is to use a formula. The formula for elasticity is the percentage change in quantity divided by the percentage change in price. Or in English, how much does quantity change when the price changes? Again, if quantity changes a lot, we call that elastic. If quantity doesn't change that much when price changes, we call that inelastic. And we're going to take the absolute value of the number we get, we're going to ignore any minus signs that we see. So if the price, as you see in the demand curve below, changes from P1 to P2, we're going to look at that in percentage terms, and we're also going to look at the percentage change in quantity. Now let's back up a little bit and remember a little math that you may once have known. If you take a big number and divide it by a small number, like 1,000 divided by the number 1, you're going to wind up getting a big number, a number greater than 1. If you take a small number, like 1, and divide it by a big number, like 1,000, you're going to get a small number. In fact, you're going to get a number smaller than 1. And so we're going to use the number 1 as kind of a cutoff to determine what's elastic and what isn't. Because if you look at the formula, if we get a big number on top, a big percentage change for quantity, when we have a small percentage change for price, that means it's relatively elastic, and we're going to get a number greater than 1. So, a demand curve is going to be elastic, meaning that there's a big quantity change relative to the price change if the number we get from this formula is greater than 1. That's typical for things that we don't really need, things like fuzzy bunny slippers or luxury goods. When the price changes, since we don't really need it, we'll stop buying it. We're going to call something inelastic, meaning that there's a small quantity change relative to the price change if the number we get from this formula is less than 1. And that's typical of things like necessities, food, clothing, or at least the bare minimum of clothing, insulin to a diabetic, heroin to a heroin addict, etc. We're also going to see something called unit elastic. And what unit elastic means is that when the price changes, quantity changes in the same percentage amount. That's going to be the case when we get a number in this formula that's equal to 1. So let me give you a couple of examples and see if you can work them out. 3 examples here. Here I'm giving you the percentage changes, so you simply need to plug them into the formula, take the absolute value of the numbers that you get, and determine whether these represent elastic, inelastic, or unit elastic demand. Pause the video and come back and see if you got the answer right. All right, those are the answers. If you have problems getting those answers, come on in, I'll help you out. Now there's another method of determining elasticity. And this method is used if you're not straight out given the percentage changes. This is called the midpoint formula, and it's also sometimes tested on the AP exam. Up to this point, I've given you the percentage changes. If instead you're given 2 price and quantity combinations, you're going to have to use this formula. I'll show you what I mean. Let's take this example. Let's say that when the price of lemonade is $1, and there's lemonade again, I feel terrible. When the price of lemonade is $1, let's say people buy 400 cups of lemonade. Let's say we then raise the price of lemonade to $3, and we find that the quantity demanded falls to only 60 cups of lemonade, and we need to find out what the elasticity of demand is. Now here I'm not giving you the percentage changes, here I'm giving you 2 price-quantity combinations. Price of $1, quantity 400, price of $3, quantity 60. What do? You use what's called the midpoint formula, which you can see on the right of your screen. The way to memorize the midpoint formula, because it can be kind of complicated, is to simply memorize it in words. It's the change in quantity divided by the average of the 2 quantities, all over the change in price divided by the average of the 2 prices, and we're going to take the absolute value of that number. So here we go. In terms of the change in quantity, we take the first quantity of 400, we subtract from that the second quantity of 60. The average of the 2 quantities will be 400 plus 60 divided by 2. And we do the same thing with price. Change in price went from $1 to $3, so change in price is 1 minus 3. Average of the 2 prices would be 1 plus 3 divided by 2. When you work through the numbers, it starts looking like this. And as you work through them further, it'll look like this. And again, because we're taking the absolute value of this number, we get an elasticity of demand equal to 1.48. And since that number is greater than 1, we know that the demand for lemonade is relatively elastic, meaning that the percentage change in quantity is greater than the percentage change in price. When we change price, quantity changes even more. People don't need lemonade. Now there's an entirely other way of determining elasticity, and that's through the use of what's called the total revenue test. You'll recall that total revenue, which you can think of as all the money coming into your cash register, is equal to price times quantity. So you're going to have to memorize a couple of rules here, and if you memorize these rules, you'll be able to figure out any kind of total revenue test elasticity question. Here are the rules. If P goes in one direction, in other words, if P, for example, increases, and we find that total revenue also increases, we know that demand is inelastic. In other words, if price and total revenue move in the same direction, the demand for the good is inelastic. If I raise my price of heroin, and I find more money in my cash register as a result of that, I know that heroin's inelastic. If price increases and total revenue decreases, in other words, if price and total revenue move in opposite directions, we know that demand is elastic. If I raise my price of fuzzy bunny slippers, but people stop buying it so much that I actually get less money in the cash register, I know that demand is elastic. If price changes and total revenue doesn't change, we're going to say that demand is unit elastic, meaning that the percentage changes in price and quantity are equal. All right, I'm going to give you 3 examples here. Again, I'm going to suggest you pause the video, look back to the last slide, and see if you can figure out whether these 3 examples represent inelastic, elastic, or unit elastic demand, given the rules I just gave you. Here are the answers. See if they make sense to you, and if not, try it again, and if not, come on in, I'll help you out. All right, now at the beginning of the video, I said that elasticity and slope are not exactly the same thing. It's true that the more vertical the demand curve is, the more inelastic it is generally, but different parts of the demand curve have different elasticities. Slope along a linear demand curve stays constant. Slope doesn't change along a constant line. But elasticity along the linear demand curve isn't constant. It changes all the time as you move along the demand curve. And we can use the total revenue test to see exactly why that is. Take a look at these graphs. On the left-hand graph, I have a demand curve. And on the right-hand graph, I'm going to graph out what total revenue would look like as we move along this demand curve. So let's start on the bottom right portion of the demand curve. Here, prices are very low and quantities relatively high. When prices are low, so is total revenue. If you only charge a penny for your product, you're not going to get a lot of money into your cash register. As you move up the demand curve from right to left, as you're raising price, total revenue will also start to rise. Charge 2 pennies for your cup of lemonade and you're going to get more money in your cash register than you would with only 1 penny. But that's only up to a point. Because if you raise your price too high, people will stop buying it pretty much no matter what it is. I don't care how addicted to heroin you are. If I make a gram of heroin, is that the appropriate unit? I'm giving away too much here maybe. If I charge $1 million for a gram of heroin, no matter how addicted you are, you're not going to buy it. Nobody's going to be able to afford it. I'm not going to have any money in my cash register. So at some point, as you continue to raise price, total revenue will start to go down. All right, so going back to what we know about inelastic and elastic demand and the total revenue test, what the total revenue test said is that when price goes up and total revenue goes up, demand is inelastic. And that's going to be on the bottom right portion of the demand curve. That's always going to be true. The bottom right portion of the demand curve is always going to be relatively inelastic. With really high prices, that top left portion of the demand curve, that's going to be relatively elastic. Again, the higher that price goes, the more people feel those price changes and the bigger the impact it has on the quantity that they buy. In the very middle of the demand curve, right where total revenue tops out, that's unit elastic. This can be an important concept going forward, because what we're going to find is that businesses, choose not to operate often on the inelastic portion of the demand curve, because they know that if they're on the inelastic portion of the demand curve, they could always raise price and collect more money. We're going to find that businesses tend to stick around the elastic portion of the demand curve, or that upper left-hand portion of the demand curve, if they can choose to do that. All right, so finally for this screencast, let's talk about what it is exactly that makes something elastic or not. There's 4 basic determinants. The first determinant is substitutability. A good is more elastic if there's lots of close substitutes. If we're talking about, for example, Coke and Pepsi, I'm elastic in my demand towards Coke, because if you raise the price of Coke, I'll really stop buying it. The quantity I demand will go way, way down, because there's lots of other substitutes. There's Pepsi and other soft drinks. On the other hand, if a good has relatively few substitutes, it's going to be inelastic. What people on heroin say, and I'm not one of them, is that there is no substitute for heroin, or the feeling you get from it. Okay, second determinant is proportion of income, which is what percentage of your income does that purchase take up? A good's going to be elastic if that good takes up a big portion of your income. Things like cars and houses. When the prices of those things change, I really notice them because they're such a big portion of my income. On the other hand, for things that make up a small portion of your income, you might not even notice the price changes. Every 2 years, I have to go into the supermarket and buy a little jar of salt. And the jar of salt says like 40 cents on it. Now they could double the price of salt to 80 cents, and I wouldn't really even notice, because it's such a small portion of my income, even my teacher's income, that I'm relatively inelastic to that price change. In fact, they could triple the price of salt, and I'd probably buy roughly the same amount of salt. It's just such a small percentage of my income. Third determinant, luxuries versus necessities. As I mentioned before, goods like fuzzy bunny slippers, things you really don't need, luxuries, we tend to be elastic towards. Necessities, insulin, water, food, we tend to be relatively inelastic towards. And then finally, time. The more time you have, the more responsive you can be to price changes. So for example, if I walk up to a heroin addict and I say that tomorrow I'm going to double the price of heroin, there's really not much that heroin addict can do about it. That heroin addict is going to be inelastic towards that price change because the time that that heroin addict has in order to adjust to it is just so small there's nothing he or she could do. On the other hand, if I walk up to a heroin addict and I say 20 years from now I'm going to triple the price of heroin, well, now the heroin addict has some time to act. Maybe they'll get on methadone, maybe they'll start another drug, maybe they'll go and try to get rehab, but they can react to that price change. All right, elasticity is a relatively complicated concept. A lot of stuff involved in this particular screencast, and I beg you to get help with it now, because elasticity is going to keep popping up along the year, so if you're having trouble, address it now. Okay.
Oh!